Right, hello everyone. We'll just be starting right now. So welcome to the CAD with Fusion 360 workshop by IE Mechatronics. So we have initially made the workshop to uh, keeping in mind the people who haven't used Fusion before. So we assume that you have some basic idea about CAD, but have not necessarily used Fusion 360 in particular before. Any experience on other CAD software such as SolidWorks or CATIA will surely help you, but it's definitely not necessary to carry on with this workshop. So today we'll just go over the basic UI and workflow of Fusion 360 along with the features and the use cases of these features. In addition, we'll also look at the introduction to digital manufacturing, which is basically the cloud resources that can be used and the features which can be used to share files between multiple users. So when you start Fusion 360, you will be greeted by a screen like this after the setup, except that on the top here it will show untitled or a start screen, and of course the main frame will be blank. So I'll start with the most important thing, which is perhaps in the corner where you go to preferences. So once you're there, um, one of the most important things you need to change is the units. So by default, it may be set to something like inches because it's the imperial system default in the US. But you should be sure to go to units for design and change it to millimeters or any unit of your choice. Uh, Also, the same can be done for manufacture and simulation over here. So these will make sure that the proportions you're inputting while making your design will be correct and consistent throughout. If anyone has any doubts, you can feel free to unmute yourself and ask during today's session because it won't take much time and we surely have a lot of time for all your questions.
Where you got this preferences window from for this changing of units?
All right, I'll just highlight it again. Is my cursor visible near the center?
Yeah, it's
Yeah.
visible.
All right, so you just have to go to the top right corner with your user icon and just click on it. And then the second option, preferences from here. So when you click that, the preferences window will come up, and then along with that, your default units will be here under design, manufacture, and simulation and generative design. So let's start with the top left corner now. This is called your data panel as visible here. So the data panel is essentially the source of all your files and it's your main folder in a sense in Fusion 360. Now here I have the group name as IE Mechatronics, but when you made your Fusion teams while setting up the software, you must have put your own name or a different default name that will show here, which is perfectly alright. So in that you have projects and further within them you can create files which will appear like so. So currently I have this example of a box opened up, which is also shown over here. And there are basic options to use a cursor to pan. Uh, that's at the bottom center here, the pan tool. Then you have orbit again at the bottom center, which is like so. And zoom again using the cursor to adjust all three parameters. One more important thing is the view cube, which is located here near the top right corner just below the toolbar. So the default position is the home position, which is the isometric right view, while you can select faces like so, edges like so, as well as corners to adjust to the default views. While you can also use the hold your scroll wheel button to pan till zoom, and you can use your mouse holding the view cube to rotate in any arbitrary direction. So I'm just going to reset that and I'm going to head back to the data panel. So now, one of the main things in the data panel is versions. Like so, this current file is in V6, that's version 6. So all files in Fusion 360 are stored with versions right from the beginning. So you don't need to create separate files every time you work on your design. So now, for example, when I highlight all 6 versions, I can see that this particular file was actually made by Krishna Raj initially, who is also a member of iMechatronics. So he started by making a cube, a simple cube like so, and then made additional versions where the box was extended and holes were added, and so on until there's a milestone one where it shows part prepared. So milestones are basically markers in Fusion 360 to show that this is a major version, and these can be used as reference points since complicated designs may have dozens or even hundreds of iterations, and each will be stored in a different version. In case I need to roll back to a previous version, I can go on the context menu, and since this is the latest version, it will show open and edit milestone. But if I go to an older one, it will also show promote. Next, I would like to highlight the workspaces, which is from this big drop down list in near the top left corner. So currently the default workspace is the design workspace, which shows the model and the parameters added to it while designing. You also have the render workspace, which helps you to make photorealistic renderings of the parts that you have designed and allows you to apply settings for the lighting and camera angles to generate high quality images from your designs without actually building them. The animation workspace helps you to create videos which highlight your design as well as its internal workings. So like in this example, a gearbox has been shown in an exploded view. This can also be used to show the same part from different views in a video format, which is very useful for animations in the form of video. Simulation, on the other hand, it helps to perform a variety of tests on your part or assembly. So the one shown here in the example of a bicycle suspension is a stress test where you apply pressure from one end and you see the loads and forces on each element of the material in your design. The manufacturer workspace is mainly used for computer aided manufacturing and computer aided engineering. Here you will be able to simulate the manufacturing of the part that you have designed from a stock material on a CNC machine such as a turning machine or a lathe, or even a 3D printer for that matter. The last one is the drawing workspace, which helps you to create drawings similar to the ones in AutoCAD, for example, from either a design or an animation. In addition to all these, there's also a generative design workspace, which helps you to create parts that are most space efficient and have the highest load bearing properties in the minimal weight. However, these generate quite complicated designs which are hard to manufacture and require special methods such as 3D printing to actually produce these. This particular feature is not available in the education versions and is only available in the full version, which is used by corporates and other people who purchase it. All the others are available in the student version. In addition to all these, you surely have the regular options to open, export, and share files using the standard design practices that are commonly found on softwares such as CATIA and SolidWorks. However, there is one main difference in Fusion 360, which is the complete integration with Autodesk 360. Now, Autodesk 360 is a platform completely online, which links all your designs in the entire Fusion 360 workspace and allows you to share them online. So for example, I want to share one particular file with you, such as this one. All I'll need to do is click. So I will right click this. And if I want to share a file with you, for example, I'll just head to share public link. And here I get a menu where it shows me a link which I can copy and I'll share it with you momentarily. So one of the main applications of this is, for example, if I'm designing a part, for example, for a supervisor in a company who is at his home or even in another town for that matter. So rather than sharing the main files every time, which for large files can go into dozens of megabytes or sometimes even gigabytes of file size, it is much easier to just share a link for preliminary inspection like so. So in this, this is Autodesk 360, which is an extension of Fusion 360. So over here you have the options to pan, tilt and zoom and measure. For example, if I want to measure distances, so I can see this is, for example, 170 millimeters in length and 50 millimeters across. Tools like this help me to easily check the part without needing to even have Fusion 360 on my device to begin with. So if I was to share this with, say, a management head in a company or someone who doesn't have Fusion 360 installed on their device, they can easily monitor the progress on the designs as well as suggest changes. For those of you who don't know, the main structure is there are different part files, and those part files are put together in a complete different file known as the assembly file. They might have different names for each particular software, but the whole concept in general is pretty much the same all across. But in Fusion 360, there is a single file which is called a .f3d file by default. So this allows you to house all uh, your entire design in one main component. In this case, it's box V6 as highlighted above. And then you have a bunch of options such as the settings for the document, the named views. These are presets for the front, top, right, and home. However, if I want to create an arbitrary view, I can just say orbit it to any angle like so, and then right click on named views and make a new named view. So if I ever want to orbit back to an arbitrary shape like so, if I ever want to come back to that view and see that shape in particular, I just go ahead to named view and it pops right back where it was. Another additional major difference in Fusion 360 is the use of a design history. And this is seen in the bottom row over here, near the bottom center. The main scroll bar here is basically your timeline identifier where you are currently in the design. And each block over here is the making of a new feature in the design. So like for example, I have 1, 2 and 3 holes. I have an extrude and I have made a box. So let's just go along with it in chronological order by dragging it all the way back. So now I have a completely blank file, which is similar to what you would see in your default screen with the untitled label. My first step in this design was to create a box. We will come to further details on how to design in solids as well as assemblies in the coming days. For today's example, we'll just start with this directly. So here I have created a box, and then the next step was to extrude one of the surfaces so that this particular face, this edge, was 120 millimeters as we had seen in the figure earlier, while this and this face remain at 50 millimeters. So now in case I want to change this, all I have to do is double click on it for the properties, and instead of 120 millimeters, if I just wanted to make it 130 because our designer requires it to do it, then we just head and do it and it's 130 now. And the same change will reflect as the other parts are added, such as the holes 1, 2 and 3. So now currently we have extended the design's length by 10 millimeters without affecting any of the forthcoming features, which is often a problem in other softwares such as SolidWorks and CATIA. because just changing one dimension can just break the entire flow and you need to redefine all your constraints. Some more of the options are seen below. We've already been over the orbit, pan and zoom features. Apart from this, we have a look at function. So if I want to look at a particular face, I just click look at over here at the bottom center, and then we just click any face that we want. In this case, the top face. So it directly jumps into the top view and scales it to fit the screen. Another option is, for example, if you zoom too far in or too far out for that matter, you have a fit option which returns you to the original size and shows your part in the full screen so that it's easier to manage. Apart from this, we have display settings. Starting with visual style, uh, you can use shaded, which shows the default part as it would appear in when it's made. Then you also have shaded with hidden edges, which was the one I was in before because it makes it easier to see the internal structure of a part without actually having to zoom in and out. There are also many different other ones with visible edges only to make it easier to identify the edges and sharp corners. You have wireframe, which shows the basic outline of the structure, and then the same with hidden and visible edges only. I'm just going to head back to with hidden edges as I was before. The next one we would like to talk about is the environment. So this is basically how the part appears on the main screen. So currently it's in photo booth, but you can use different backgrounds such as this dark one, or for that matter a blue, or even an almost gray color. These are useful when you have parts in colors that conflict with the background color so you can see them more easily. The next also allows you to give more effects such as the ground plane, shadows, reflections, and so on to get a better preview on the main screen itself without having to render it each time. Then object visibility shows you the option to choose planes, axes, points, sketches, etc. We'll get back to all these while we are teaching the part design and the assembly design, but this makes it easier to select individual features. Then you have orthographic and perspective camera settings and a ground plane offset. Now the grid feature allows you to this is used mainly in sketches where you need to set dimensions and you need those to be very accurate. So when you turn on snap to grid, it will basically allow you to set points at increments of a set distance. Usually it's 1 millimeter, or if you zoom in and out, that might change accordingly as well. This helps you to make precise measurements so that the small errors do not cause your design to fail when you send it for manufacturing or so on. The last option is viewports, which basically allows you to open multiple views at the same time. The viewports button is at the bottom right corner of the bottom bar, as highlighted by the cursor here. So this particular view by default shows you the front, top, side, as well as perspective views for the same file. And here you can pan and orbit each one as per your desire, so that you're able to see every piece clearly while making changes if necessary. You can also desynchronize them, so changes in one do not necessarily affect the other. And you can return by using the single view option on the same menu. That is right here. Now it's multiple views. When you're in the mode, it will show you single view mode as well. In addition, you have comments. So for example, Nihal here has put a small comment over here for the initial design, which we can click to view, where it shows the end of the one particular hole in the design. Similarly, you can put multiple comments and it's easier for many designers to see it at the same time. In addition to having one main file with separate files for each body within it, you can also use files within each other. So that is where the uses and used in tabs come. Since this is an independent design with just one part in it, these fields are empty in this case, but in case you import a file from import a design from a different file, these will get highlighted in the users tab. And if you use this design in another file, it will show in the used in tab, which helps you to identify the effect of the changes that you make in the future. You also have a drawings tab where you can generate drawings from the drawing menu right here to create CAD drawings, which make it easier for the field labor to manufacture the parts. Now, the main structure of uh, the parts in Fusion 360, as I already mentioned, you have a main component, which is highlighted here. Apart from that, you also have bodies. Now, in this case, it's a simple part, so it has only one body. And what are bodies mainly? So, bodies are essentially closed volumes of basically closed volumes in Fusion 360. Any closed volume, even if it is a hollow sphere with a certain thickness, that would classify as a body. Now, when you split, say if you want to create a division here along the center, along this line, it will create two separate bodies as they're separate closed surfaces with a gap between them. However, you can use bodies while either merging and while extruding and cutting out of them for various design purposes, which will be highlighted later on. Now, components, on the other hand, are those sets of bodies and other features which have a single origin. In this case, the origin is here. So these components are used to create assemblies where you apply constraints on uh, these particular assemblies between each other, and that helps you to create the defined motion that is required in the assembly. So that pretty much covers the basic UI of Fusion 360 in general. And if there are any questions at this point, I would be happy to answer them.
Can you tell again how did you change the properties of the box?
All right, sure. So, for example, the box, right? So, I'll just head at the design history marker and scroll it all the way until just after the box. Oh, wait, I'm sorry, the browser's hiding it. Now, I hope it's more visible. So, here I see box primitive 1, for example. So, when I double click it, it automatically opens a menu called edit feature. So over here, I am able to define, in this particular case, the length, width, and height of the particular box. And since there's no other body in the diagram until in the file until then, so I'm just going to create a new body and hit OK. And that creates the box. Similarly, if I wanted to extrude the box, that is what I changed in the last example. You head over to the particular instance of that feature, like so, and double click it, where you get a similar edit feature box, but it asks you for constraints based on this particular feature. So, for example, here my profile pane is this particular face selected here, which is hidden on the right side. My start is the profile plane itself, which is the default option. And I want to extrude it by one particular side, which in this case is outward, shown by the blue arrow on the right side. We also have options for both sides, symmetric as well as asymmetric. So you can apply extrusions in the forward and backward directions and have individual lengths for each one of them. You can also apply extents with respect to other objects or just through the entire part in general. And here you can choose the distance, which in this case is 130 millimeters, and you can also choose a taper angle, which makes the face smaller or larger while extruding it. And here in the operation, So this is where the whole concept of bodies comes in. So the default one is join over here because I have only one body and I just want to extend it by 10 millimeters more. However, if I had to say maybe cut a hole just through a part of the thickness of this particular box, I would make a sketch and choose the cut option to just make a hole in it for a certain thickness. In case I just want the particular intersection region, I'll choose the option intersect or just new body if I just want to make a different one altogether. There are similar options like this which vary with each feature, which will come over. Like similarly, the whole feature, which I opened in the same way, has the same edit feature box, but with a lot of different parameters. Here again, I get to choose the face and references, which are optional. And then I get for even further options to choose, say, what type of hole I want or how I want it to be tapped and drilled. You can also set the individual dimensions for how deep we want it, the angle of the tip, and the diameter, like so, in these respective fields near the diagram over here. Are there any other questions?
Could you explain that uses used in drawings part on the left side of your screen?
All right, so basically, the default one that you open when you click on versions over here is the history tab. So here it shows you all the versions of the file right since you made it. So in this case, the version 1 which you would see on the bottom left corner of your screen is where um, Krishna created just the box. And then further in version 2, for example, it was extended. And then versions 3, 4 and onwards added a few holes in the part, just for example. And at the top appears the current version that is in use. The users
How is,
and used in.
sorry,
Sorry.
sorry to disturb. How is this different from the thing you were doing while you were scrolling on the bottom of the screen? Like you are also
All
showing the
right.
history that. How is
Yes,
that
yes.
different?
That's a very good question, actually. So each um, version over here, for example, on the left side of the screen, acts similar to saving different versions of a file as different files in another software like CATIA or SolidWorks. So, for example, in those softwares, you would have to make a file, say box v1, and open that, make the changes, and then save it as box v2, and so on. So that is simply replaced by this version history, which allows you to access all the versions in a more coherent and easy way. On the other hand, the design history panel over here allows you to, it's basically a log of everything that was done since the file was made. So if I just opened this design like how you are seeing it for the first time, all I have to do is refer to the design history, go all the way back, and I can see how exactly the part was made. So just by opening this file, I know that this particular part was made by making a box and then extending the box and then adding the three holes one at a time, like so. The design history at the bottom allows you to see the features that were added in the order in which they were added. So for example, if I made a different version of this file, which is basically control S. So when you save, it doesn't save as a file, it saves as a new version in the cloud, which again goes to help with the whole collaborative working and cloud computing usage of Fusion 360.
So, like basically, the bottom part tracks the changes in that file, and the left-hand side part saves different versions of that file. Is that something?
Yes, that's right. So for
Okay.
example, in this file, this is version 6, for example, I have 5 operations that I've performed, which is one box, one extrude, and then 3 holes in succession. If I open, say, version 2, all right, so this will open in a new window. So now we're in box V2. Now, as we know, this has only the first 2 steps. Say the first extrude and then uh, the first creation of the box and then extruding the box to make it longer. So we know how exactly this particular version was made. And similarly for the other file, we saw five operations here in which we had 3 holes as well. Now say for example, I close this one and I hit back. If I say want to make a new hole, for example, I'll just uh, use this particular face, and I'm just setting arbitrary dimensions over here, so there's no need to keep a strong eye on that. I'll just make it 20 millimeters, for example, and then I'll just hit OK. So that creates a new 4th hole, which is shown over here. So this particular part was before I made the change, and then just by scrolling the timeline later on, we see the new hole added. Now, if I just go ahead and hit Control S, which is the save option, which is standard all across software, here I can just type version description, for example, addition of 4th hole. And in addition to that, I can even create it as a milestone. And in milestone, I can maybe write shown in workshop day 1. And then I'll just hit OK, and then you'll see after it updates, it will be uploaded on the cloud, and then it should show version 7 as highlighted on the top here, as well as the entire version history has updated as well. And it also shows a flag here which indicates the milestone, and here it shows shown in workshop day 1, for example. This helps to better keep track of different versions of files, so that in case you need to go back to a previous version and make some changes based off of that to use as the final part, you can do that really easily without having to look through a dozen, perhaps hundreds of different files which will which will take up gigabytes of your memory. Instead, you can just use this simple interface to make all the changes you want with minimal time required.
Are there any, facilities to have multiple versions of the same thing, like branching, kind of like what we do in Git as a version control system, like the multiple versions of the same thing, like from one version you're creating different changes and all of them are tracked. Is there something like that?
So you can't do that in individual files because they are numbered sequentially. Like for example, in this case, it's V7, right? So you cannot have different, like how in Git, for example, you would have different build versions, I guess. So instead, what you can do over here is you can just go to the conventional save as and save it as an F3D file and just open it and create a new part in a sense over here, importing that particular file. So that will both inherit the version history as well as the design. And you can just rename that file with the name of the second branch that you want. Like for example, branch box test. So in that case, I'll just head to save as and then save that as a .f3d file on my computer. And then I'll just import that back in and save that as box test, for example, and then I can make the changes in that branch separately.
Uses, used in, and drawings, like beside history, the options there.
All right.
Thank you.
So this particular in the browser, if you see box v7 is one particular design, right? So it's its own .f3d file in a sense. It's an independent piece. So over here, Fusion also allows you, like say if I had a different version with say a shaft that I wanted to put here that was in a separate file called shaft.f3d. So I can just head to the file options and import that particular design over here in general. And the advantage that has is that when you import designs in Fusion, if say I wanted to go to that particular shaft and make it longer or shorter, or maybe add some grooves or threading in it, I can do that independently. And the changes in that file will reflect here automatically because that part is imported here, for example. So that will go in the users tab. So if I had a shaft over here, that shaft would be shown in the users tab as say similar to just above, like how it shows your box V7. Similar here, it will show shaft V1, for example, or That version will progress actually as you're updating that independent file. Used in is the exact opposite. So if I open the shaft file in Fusion, for example, it will show that that shaft file is used in this particular example of a box. That helps me to keep track that if I make any changes in this particular file, it will also reflect in the box design as well. So that helps me to keep track. So if in case I need different shafts for two different pieces, I'll make a new file using the same process I mentioned earlier, and then maybe assign one to one part and one to the other, and then work on those independently. Drawings, on the other hand, is when you make basically the 2D sketches. Like if you're in engineering, you would surely know using of graph paper to make different sorts of views in engineering graphics or similar subject. So those can be designed digitally. So you can just import the part and make a top, front, side isometric views. And then you can basically plot that on an entire sheet and have it ready to print. So all those drawings that are generated will come up over here. And again, similar to all the other things, as you update the design, it will also update the drawing file with the changes in the design. So you don't have to go and generate drawings every time.
Okay, thanks. That was helpful.
Are there any further questions? All right. So before we wrap up today's session, I would also like to highlight that we will be requiring a submission from your end of a design file using the similar process which I showed earlier. To share the files. Similarly, like similar to how I shared the link for this particular file with you, we will require you to make a design on your copy of Fusion 360 and send that link to us so that we can check that you've been able to make progress throughout the workshop. So now what part has to be made and the steps involved in it will be detailed across day 2 and day 3. So day 2, which is tomorrow, is going to deal with the design of parts, which is essentially this space which I had initially skipped uh, for today. So here you have the option to create sketches and modify them with different options like filleting, combining, creating shells, moving around pieces, etc. And you'll be using these tools in the next couple of days to create your own design, and we will require the submission of that shortly after the workshop ends. So in case you are not able to catch on with it immediately during the workshop itself, we will record all days of the workshop like we are recording this particular one, and we will share it to you shortly after each day. So you could perhaps go through those recordings, and then that will help you to maybe keep track. And of course, if you have any doubts, you can put them on the WhatsApp group at any time, and one of us will be happy to help you out with whatever it is.
I have a doubt.
Yes,
We
sure, please go ahead.
we see in the timeline, right, the progress we make.
Yes.
Yeah. So suppose we import a CATIA file and change convert it into Fusion 360. Then why don't we get the timeline?
All right, that's
No,
I understood your
no.
point. Sorry.
Yeah. I just want to continue. Uh, we import the CATIA file. In CATIA, we don't have timeline. That's the story, but that's a different story. But after that, when we make changes to that file, why don't we get some the timeline?
All right. So about that, the CATIA file, like as I had already mentioned earlier, CATIA and even other softwares like say SolidWorks don't have a feature to record the design history. So when you import that file, the process used in making that file does not get saved in the file itself. It just basically transfers the look of the file and the design in particular with all the dimensions and what is solid, what is hollow. So there's no track in a sense of how the part was initially designed. So for further procedures, again, since you don't have a proper definition of how the particular design was designed until then, it is like it is like basically starting a design history from step 7, for example. So there's no way I can keep proper track like say I can't start a recipe for any particular dish from step 7 and just skip the first step where I just say make,
Yeah.
like for example, make cake batter. So even if you have the steps outside of that, it's pretty useless without knowing what was done before. So that is the main reason why when you import any file from, say, CATIA is a very good example, but other than that, if you import something like STL or step files, which are commonly available online, you won't be able to get a design history for those particular files.
What are the extensions in Fusion 360 we can with which we can convert the files into Fusion 360?
Alright, so the default file formats of Fusion 360 are .f3d. So one, like the main one is .f3d. So this particular part, if I wanted to save it, it would save as a .f3d file, which will record both the design itself as well as the design history. So when you import that file, you will also get the design history and the proper timeline coming along with it. Another file format is .f3z. So the only difference between .f3d and .f3z is you use .f3z when you have other designs also imported along with that particular fusion file. So if, like I took an example of making a shaft to go along with this. So if I had a shaft in another file that was imported, it would show in the use this tab in this particular design, which is why I would have to save this file as a .f3z file. So when I import that, it will automatically know that there is another part that is required and it will ask me for it. So when I say open a .f3z file of this box with a shaft, it will by default show the box but not the shaft. And then it will give you a pop-up window asking you to select the file where this shaft is. So once you import both of them, that is when you'll be able to see the design properly.
Okay, okay, thank you.
I have a question.
Yes,
Can we
sure.
view
Please go
the,
ahead.
can we view the design history in the browser, or can we only view in the Fusion 360 app, like the software?
On the browser, it just allows for, since of course a browser web page is not nearly as powerful as a software like this. It is not possible to show the entire design history in the browser. However, when you create a share public link like how I had done earlier on today, it will by default create it of the latest version, and you can open that and see all the dimensions, etc. in that. If you wanted to say show an older version instead, you can open the older version like I had before by going into history over here. And for example, if I wanted to open version 3, so I would just select an open version 3 and then share the link for that particular version, which will help the person on the other end to see the older file from their browser. Are there any further questions from anyone?
Like building on the previous doubt that once a CATIA file is imported into Fusion 360 and converted into a Fusion 360 compatible type, why isn't like you said there's no track of the initial model, right?
Yes, that's right.
But like, say you make a change on it, why is it like not possible to track the changes instead, like to keep a track of version?
Alright, so how Fusion 360 saves the file is essentially in these steps in general by default, right? So it doesn't actually save the design as a whole. It saves the steps as shown in the timeline. So whenever you open a file, the file itself just contains these sets of instructions. Like for example, make a box of these dimensions, then extrude one surface, and then make each of the holes with their individual parameters. On the other hand, when you use a CATIA file or an external file in general, how it saves it is essentially like a complicated mesh of all these surfaces. So if you've seen the breaking down of a 3D model into an STL file for 3D printing, for example, you will know that the part is essentially broken down into, like each surface is broken down into a mesh of a bunch of triangles. So the coordinates of each of these points for all the surfaces combined is how the file is defined. Now, it is impossible to track each point with respect to the design process as used in Fusion, which is why it doesn't save the design history for that.
Because each step is referencing the previous step.
Yes,
So,
that's right. So since you don't have a previous step to refer to before that, it cannot follow that design flow in a sense,
yeah.
which is why it automatically reverts to the older, more conventional design process, which has its disadvantages, but it's mainly kept in Fusion 360 for this main reason, that is compatibility with other versions. Because since the software itself is newer, they pretty much expect that all the people are going to be migrating from other softwares. So they need a sort of compatibility to make sure that they can make the switch easily.
Yeah. Thank you.
If anyone else has any other doubts, please feel free to unmute and ask.
Will you teach manufacturing as well?
I can perhaps show you a demonstration. Just one second. Here is a file, for example, which was made again using Fusion 360, showing the milling process. So over here, I have so in the yellow rectangle, basically I've defined the stock, which is the base piece out of which we are milling this part in this particular instance. And then I have made a bunch of features which again will be visible in the design workspace. So over here, for example, I have started out with a sketch, a basic sketch, and then I have individually extruded the sections to the heights required. So this particular piece, when I head over to the manufacture workspace, I'm just going over it real quick here. So then you have options for simulate. So in this particular instance, I have a milling operation. So I'm just going to make the tool a bit transparent, and I'm going to start it here. And when I hit play, basically it simulates the entire tool paths that are required to machine the entire piece from a basic block of metal. So now in this particular instance, what you saw first was the facing process, and then you're able to see now the milling of the edges, and then you'll eventually see the outer edges, and then the top edge, and then the holes, for example. So this is just an example. You don't need to catch along with this. It will take a while for sure, but we will definitely cover a bit more on this in the future as well. Alright, so for example, over here, I have a basic design of a keychain with the iMechatronics logo on it, for example. It could be pretty much anything. So while we already mentioned the manufacture workspace for machining and all that kind of stuff, here, for example, if I wanted to 3D print it, I just head to tools on the top here and make, and there's a 3D print option right there. So now, for me, in my particular case, I have designed this for 3D printing on a Fractalworks 3D printer that uses a separate software called Fractree as the 3D slicer. You'll see it in the bottom of the 3D print dialog box next to application. So all I have to do is select the particular body that I want to print. In this case, I'm just want to print the top half, and then I hit OK, and that generates the file in the background. So here when I zoom in, I can see right here that I have directly imported one half of the keychain file into my slicer, and then I have additional options over here to define the parameters for the particular 3D print I want to do, and then slice it, for example, and then just send that over to a 3D printer to like, for example, I'll just hit slice over here, and I will go over to layers just to show for example. So here, this particular case, it has 25 layers. So you will be able to see right now a bit more clearly that each basically cylindrical piece is the path that is taken by the 3D printer's extruder. And as I progress with the layers, it will build one layer at a time until the entire file is built. And that is just natively exported from Fusion 360. So there's little, there's barely any compatibility issues at all. The same works with almost all slicing softwares as well, not just this one.
How did you get the Mechatronics logo on the keychain?
All right, so now the easiest way to see this is to just go back in the design history. All right, like with most other samples. So in this particular one, I have started with making the outlines. So in this case, I have also named my all my processes below. So like for example, this one is the outline. Then I have extrude top base, and like so to rename them, I just right click them and hit rename and then name it to whatever I want, so that it's easier to track later on rather than just having extrude 1, extrude 2, and so on. So now I have logo over here, for example. So I just click it and I show that is the logo. So I'll just head my design history marker right there and I'll make the sketches visible. So my logo in particular is imported as a sketch. So how I did this in my case was I went into the solid tab and insert and inserted an SVG file of my logo. So I already had an SVG file which I could have exported directly out of Illustrator, for example. And then I just imported that into this particular file and then I scaled it to fit over here. And then I used the individual parts to create the logo in 3D.
Okay, and how do you make the SVG file?
So that comes more under the graphic designing process. So the person who designed this logo, in this case, another one of our club members, Sonder, designed this logo on Illustrator. So in that particular case, he can export an SVG file, which is very similar to a drawing file in a sense, directly from Illustrator as an SVG file, and then I imported that into Fusion. Apart from that, you also have options like, as you might be able to see here, I'm not sure if it's loaded just yet, Canvas. So Canvas allows you to import, in a sense, a photograph into Fusion, which you can use as a reference. So in one example, which is shown here in the tooltip, like for example, if you want to make a car, you can just make a sketch or any file in an image format, which could be like a JPG or PNG file with your photo that you want. And then you can scale it to the size that you want in Fusion and then use that as a template to create all the points and then maybe create surfaces and bodies to actually bring that design out in 3D. Apart from that, you also have options to insert meshes. So OBJ and STL are the common file types for meshes, and these are most widely available online when you go search for files to 3D print. So you can also import those directly and then use this software to make any changes if you want and then 3D print it. And you also have an option below right here called insert manufacturer part. So with the increasing amount of time that Fusion has been around, a lot of major companies have adopted Fusion 360 and have made their designs in a native Fusion 360 format. So they're easy to import and use for more complicated designs. Like for example, Epson also makes industrial robots. You might know them more commonly for their printers and scanners, but industrial robots is also quite a big part of what they do. So all of their industrial robots are available in a native Fusion 360 format on which can be accessed through this particular link here. And they can be imported directly and any changes can be made. You can add additional parts to simulate a pick and place process right from here, and a bunch of other purposes you can use it for. Alright, so I guess everything's covered for today pretty much. So if you have any further doubts later, you can surely put them on the WhatsApp group and we'll be happy to answer them at any time. Also, tomorrow we will continue with part design where you will use more tools in the solid workspace to create sketches and other parts out of those sketches, as well as day 3 where you will learn more about assemblies. So stay tuned for the next days as well, and we can call it a day for today. Thank you all for attending, and we hope to see you all tomorrow.